This project's focus was the nickel-3 titanium or ADA phase in nickel-based superalloys. The main goal of this project was to increase this ADA phase, especially at high temperatures, to increase its strength, as well as to decrease the cobalt content in order to reduce the cost and price volatility of this alloy. Matt Wong's V1TA1 alloy's weight percent gave us a baseline of the elements used in this alloy, which we used to begin looking at what factors we wanted to change. Cobalt and chromium are the two factors that were explored. The levels were determined using ThermoCalc and Minitab software. Chromium was chosen because it is cheaper, but can replace most of the cobalt and still increase the ADA phase, due mainly to the two elements' similar properties, such as chemical volume effect and electronegativities. This led us to our hypothesis. If we replace most of the cobalt with chromium, then we will have more ADA phase at higher temperatures, because they have similar electronegativity and their chemical volume effect is zero. By running a screening DOE, we found our levels to run a full DOE, and using these factors and levels we obtained the response of volume fraction of ADA phase from ThermoCalc. We also obtained a main effects plot from Minitab to determine if it was worth continuing with our hypothesis. These plots show that at 900 degrees Celsius there is a continuous increase in ADA, but there is not at 800 or 850 degrees. Now knowing that it was worth continuing, we used Minitab again to give us the final levels we wanted to test. ThermoCalc can be used to evaluate these levels one at a time to give us each level's specific volume fraction of ADA phase. Keeping in mind our hypothesis was to increase the amount of ADA phase at a high temperature while also decreasing the amount of cobalt, we assessed each level in ThermoCalc and proved it to be true. This can be seen by the fact that our highest volume fraction of ADA was 0.157 at 900 degrees Celsius, obtained with a 13.29% cobalt and 30.51% chromium. Comparatively, Matt Wong had a volume fraction closer to 0.14 with both cobalt and chromium closer to 20%. The level we chose was determined to be the best of our options using a metric that minimizes the weight percent of cobalt while maximizing the volume percent of ADA. This highlighted contour plot helps prove our hypothesis by showing the darkest shade of green for chromium, most prominent at 900 degrees Celsius. Using the information gathered from this research, our team proposes an aging temperature of 900 degrees Celsius.